Here is the next example on polar plot. So the question is, consider the unity feedback system having an open loop transfer function g of s is given like this. Sketch the polar plot and find the phase margin and gain margin. Okay, now here this 5, 40 and 1, 200,000, these are all corner frequencies similar to the border plot. Now what type of system is this? Its type we define based on the number of poles at the origin. So I have 3 poles, so type is 3. And what is the order? Order is 5. Okay, so type 3 order 5 system look like this. Okay, but that's according to the video 2. But if you look at all the equations I used in video 2, they do not have any numerator equation or numerator equal to 1 all the time. So it means there are no zeros in that transfer function. Okay, so but here I have zeros. Because of this, the phase angle is going to be differ. The final phase angle is going to be differ. So I would say the order of this system is going to be, probably I may need to redo the video 2. Here order of the system is number of poles minus zeros. So I would say order of the system is 3. So third order system and third type system, the graph is going to be something like this. So this is a wrong graph. The final graph is going to be something like that. Okay, so that's one major change in this video you need to remember. Okay, so when it comes to the order, probably we're going to do poles minus zeros. Now here he mentioned it's a unity feedback system, so the given g of s is this. Okay, and unity feedback system, that's u, and y, that's the whole transfer function. Now we'll find magnitude. So I'm going to substitute s equal to j omega. So magnitude is nothing but square root of 1 plus omega over 5 whole square times square root of 1 plus omega over 40 whole square divided by omega cube square root of 1 plus omega over 200 square and times square root of 1 plus omega over 1000 square. Okay, now when it comes to the phase angles, all the numerators we will add them, denominator subtract them, similar to the Bordeaux plot. Okay, so tan inverse of imaginary over real, so omega over 5 over 1, tan inverse of omega over 40 over 1. So over 1 I'm not writing them, and tan inverse of omega over here, real part is 0, so omega over 0. So minus y, it is 3 times, it's omega cube. So something over 0 is infinite, which is 90 degrees. So this is minus 270 degrees. Minus tan inverse of omega over 200 minus tan inverse of omega over 1000. Once we have this magnitude and phase angle equations, now our goal is define the omega values. So the important point here, to draw the polar plot, make sure you have to have magnitude 1. Okay, and then some other points. Okay, but you have to have this magnitude 1. So choose a omega value where you're going to get the magnitude 1. So trial and error method most probably. First, if you want, you can try with this corner frequencies 1200, 5, 40 and 1. And then whenever you get closer to unity, you can choose around that numbers. Okay, here if I substitute 1000 over 5, which is 200 square, okay, square root of 200 square plus 1, probably it's going to be 200. This is approximately 1000 over 40, which is 25. This value approximately 25, 200 times 25, but here it is 1000 cube. So 200 over 25 or 1000 cube, very very small number. Okay, actually I calculated that number and I have that approximate value as 0.69 micro. Okay, so it's very far away from 1000. So if I choose 200, I end up with 17.6 micro. Okay, Still that's far away to the unity. So what I did, I chose, after substitution for numbers, I chose 1. Even if you look at the inspection method, if I chose omega equal to 1, this is 1 over 5 square, which is 0.2 square, very small number. So this value you can choose this 1, and 1 over 40 square, very small number, we can ignore that, so that value is 1. Omega cube, which is 1 cube, that is 1. This value is 1, this value is 1 approximately. So at omega equal to 1, my magnitude is going to be unity. Okay, so I chose that number, and I substituted omega equal to 1 in this equation. I end up with phase angle as minus 258 degrees. Okay, so based on this 1, I end up finding for 0.6, 0.8, and 1, 1.2, 1.4, and also 1.6. Okay, those are the numbers. I found the magnitude. Now to draw the polar plot, okay, so we have to have unit circle. So I chose the magnitude. This is 0.4, 0.8, 1.2, 1.6, 2, 2.4. So anywhere on the circle, the magnitude is 2.4. Anywhere on this red circle, now I'm using green, on the circle, it's unity. Okay, now when we look at the first point, so I have up to 2.4. Okay, so if I choose 0.6, magnitude is 4 point. And don't worry, in the polar plot, I did not indicate omega value anywhere. Okay, I'm taking only these two numbers, magnitude and phase angle. So magnitude 4.62, it's already out of the graph because the value here is, I have only 2.4. Okay, that's 2.4, that is 2. Okay, so move on to 0.8. So I have 1.95 at an angle of minus 260. So the phase angles are given 0. So this is minus 10, minus 20, minus 30, minus 60, minus 90, minus 120, minus 150. I can say minus 180, minus 210, and minus 240. Okay, 250 and 260, minus 260. So 1.95 approximately 2 at an angle of minus 260 degrees. So that's my first point. So the next one is 1 at an angle of minus 258. 1, so 1 is, this is the unit circle, at an angle of minus 258. Okay, 260 and 258 almost same, so probably closer to that circle. Okay, and I also have 1.2, which is 0.5 at an angle of minus 254, 0.3 at an angle of minus 256. So I have 0.5, so this is 0.4, 0.6, 0.5 is somewhere there. Okay, with an angle minus 254, and 0.3 at an angle of minus 256. So 256 is also approximately close to that number. This value is 0.364. So this is 0.4, so 0.364 is somewhere there. Okay, so this is my final plot, polar plot. Okay, that's my plot. Now our question is find the gain margin and phase margin. So phase crossover frequency, we need to know phase crossover frequency. Definition for phase crossover frequency. So here is the definitions for the phase crossover frequency, gain crossover frequency, gain margin, and phase margin. So phase crossover frequency is nothing but it is the frequency at which the phase of ZZ omega is 180 degrees. So if you look at our polar plot, it's look like it's something like this. It is never crossing 180 degrees. So in our case, phase crossover frequency is 0. Gain margin is nothing but it is defined as the inverse of the magnitude of ZZ omega at phase crossover frequency. So I don't have any phase crossover frequency for this because it is not crossing that 180 degrees anywhere. So gain margin for our system is 0. Gain crossover frequency, it is the frequency at which the magnitude of z omega is unity, and phase margin is nothing but gamma is 180 plus phi zc. So if you look at our example here it is. So here is the unity. At unity, what is that angle? I mean, we already found that as minus 258. So phase margin is nothing but 180 minus 258, which is minus 78.69 degrees. Okay, that's the gain margin and phase margin. I'll stop this video here. If possible, I'll make one more. If not, I will start doing the root locus. Thank you. Next topic is root locus.